11.6 conditional probability. So before we get started, I'm warning you now that 11.6 conditional probability. So before we get started, a quick warning. I'm not editing this video, so if there are mistakes or anything like that, I'll just erase them and continue. And if you hear a little puppy, that's because one is in here with me. He's not allowed to be by himself in the rest of the apartment, so he gets to be in my office with me. So, conditional probability. In general, the probability of event E2 occurring given that an event E1 has happened or will happen, the time relationship does not matter, is called a conditional probability and is written the probability of event 2 given that event 1 happens. For any two events E1 and E2, the conditional probability PE2 given that E1 is determined as follows. So here's our formula. So the probability of event 2 happening given that we have event 1 happening is n times E1 and E2 over n times E1. Alright, example 1. A single card is selected from a deck of cards. Determine the probability it is a club given that it is black. So, we have the probability that it's a club given that it's black. You can either write it like that, or if you're being lazy, you can say C given that B. It means the same exact thing. So, how many clubs do we have in a deck? We have 13. So we have 13 clubs. And how many of them are black? All of them. All clubs are black. There's my puppy. He wants my attention. So since there are 13 clubs and all of them are black, that is 13 clubs. Given that, how many are black? How many black cards do we have? 26 black cards. So 13 divided by 26, we get 1/2. So you have a 1 in 2 chance of getting a club, given that it's black. The background noise is courtesy of Parks and Rec. 250 patients who had knee surgery or knee, hip, or heart surgery were asked whether they were satisfied, dissatisfied, or neutral regarding the results of their surgery. The responses are given in the table. If one person from the 250 patients were surveyed is selected at random, determine the probability that the person, and we have 4 sets. So part A, we want to determine the probability that the person was satisfied with the results of the surgery. So P, satisfied. So how many total were satisfied? 210. And out of that 210, how many people did they ask? 250. When we simplify, that's 21 over 25. So if you wanted to pick, I keep wanting to write the T first, and figure out how many are satisfied, 21 out of every 25 picks, you would get a satisfied patient. Alright, part B. How many were satisfied with the results of the surgery given that the person had knee surgery? So we want to know satisfied given that it's a knee surgery. So how many people had knee surgeries that were satisfied? 75. Total, how many people had knee surgeries? 95. So satisfied given that it's a knee surgery. 75 over 95, we have 15 over 19. That's P, satisfied given that they had a knee surgery. Alright, part C. How many people uh, if we picked one, we're dissatisfied with the results of the surgery given that the person had hip surgery. So we want to know dissatisfied given that they had hip surgery. So people that had hip surgery that were dissatisfied were 15. Total number of people that had hip surgery were 105. When we simplify that, we get 1/7. So 1 out of 7 picks, you'll have someone that is, if you're only talking about hip surgeries, you'll have them be dissatisfied. Part D. So the given that part is like, that's the pool you're gathering your information from. How many people had heart surgery given that the person was dissatisfied with the result of the surgery? So we have P, dissatisfied, given that they had a heart surgery. So dissatisfied heart surgeries were 5. Total out of everyone that had a heart surgery, so everyone that had a heart surgery, so let me back up there. We want to know dissatisfied but with the heart. So how many people had the heart surgery that were dissatisfied? 5. How many dissatisfied people did we have in the results of the surgery? You see how it's worded different from C to D? It was given that they had heart surgery. This is results of surgery. Results of surgery that were dissatisfied were 40, which simplifies to 1/8. Example 3. Consider the circles shown to the right. Assume one circle is selected at random and each circle is equally likely to be selected. Determine the probability of selecting a red number given that the circle is green. So we want to know the probability that you pick a red number given, a red number given that the circle is green. So if you want to write that the lazy way, you could say R given that it's green. But see how, like, R given that it's green, R line G, that doesn't really make too much sense. That's why I like to write it out. So how many bubbles are green? So you have 4 green circles. And how many of them are red out of the green? 3. So there's 3 red numbers and green circles. So 3 out of 4, you can't simplify that. A family has 2 children. Assuming that boy and girls are equally likely, determine the probability that the family has 2 girls, and so on. So for part A, we want to determine the probability that they have 2 girls. And anytime we kind of talking about genetics and stuff like that, we always bust out our tree charts. So we want 2 children. We have the first child and the second child. The first child can either be a boy or a girl. The second child can either be a boy and a girl, right? And then we can also have another boy and a girl. So we could either have boy boy, boy girl, girl boy, girl girl. So our sample space is boy boy, boy girl, girl boy, and girl girl. That's fun to say. So what's the probability of the family getting 2 girls? Well, one of them is girl girl, and we have 4 in the sample space, so 1 out of 4 chance. Alright, part B. Determine the probability that the family has 2 girls if you know at least one of the children is a girl. So since we have our T-chart, we can actually just base all of our information off the T-chart. So part B is the probability that both are girls, so both G, given that at least one is a girl. So we want to look at the ones that have girl in it. There are 3 girls, so the sample space, 3 of them have a G in it. 1 is both GG. So both girls with at least one girl. There's 3 groups with at least one girl, and only one of them is girl-girl. So the probability of that is 1/3. Alright, part C. 2 girls, given that the older child is a girl. So what we want is 2 girls, given that the older is a girl. So we want the first girl. So out of these, 2 of them have girl first. One of them is girl-girl. So that's 1 out of 2. The table shows the number of cars and trucks that use a certain toll road on a particular day. The number of cars and trucks that used and did not use an electronic toll pass on the same day was also recorded. Here's the question. I forgot to put it in and type it in. If one of these vehicles is selected at random, determine the probability that the vehicle selected was a car. Round to 4 decimal places. So we want to know the probability of the car. So probability of car. So how many cars total do we have? 1499. Out of those cars, we have a total of 2,449 people who use the tolls. When you divide that, you get approximately 0.6121. It's said to round to 4 places. So we did. That's about 61% of the time. It's going to be a car. Let's add in a different example here, just for these notes to better suit us for the worksheets and for the homework. So part B, let's say the same question, probability that blank, so probability, blank blank, or dot dot dot, that you have a truck, given that they did use the toll pass. So how many people used the toll pass completely? So total people who used the toll pass was 800. How many of those were trucks? 300 of them. We're not going to round to the nearest decimal place for this one. We'll keep it as a fraction. So we can cancel out these zeros, and we get 3/8. So 3 out of 8 times, if we're talking about people who just use the toll pass, 3 of them are going to be trucks.